Good morning, student. Let's start today's class. In today's class, we are going to discuss about passive transducer. Okay. In previous class, we have already discussed about the active transducer. Today, we will discuss passive transducer. Okay. So, in previous classes, we already known about the difference between passive transducer and active transducer. In passive transducer, there is no need of external source to work the transducer or to operate the transducer, but in passive transducer the external source is needed to operate the transducer. Okay, so the first passive transducer is transmitter transducer. Okay, first sorry, thermistor transducer, sorry, thermistor transducer. Okay, it is used to measure the temperature, and based on the fact that the temperature of the thermistor is a function of temperature and decrease with increase the temperature. Okay, if R0 is the resistance of the thermistor at 0 degree Celsius, then the resistance at temperature 0 degree Celsius 0 degree Celsius is this R theta. Okay, uh, ignore this. Basically, this thermistor transducer that when the temperature decreases, the resistance of this thermistor is also decreases. Okay, and when the temperature increases, then the resistance of this this transducer increases, and according by measuring the resistance, okay, or by measuring the current flowing through this circuit, okay, we can calculate the temperature. Okay, so this is the basically the principle of the thermistor resistance, transducer. Okay, now next one is potentiometer transducer. Okay, it is a passive transducer. Here you see, to here one external source is applied. Since it is a passive transducer, external source is applied. Okay, here also you see in the potential transducer, here also external source is applied. Okay, and potential transducer, you know, the potentiometer. Okay, the working of a potentiometer is what? We use the potentiometer as a variable resistor. Okay, so we can vary the resistance through the potentiometer. Okay, here you see the potentiometer. It is a passive transducer used for measurement of displacement, pressure, force, gas flow, then liquid level, etc. It is resistive transducer. Okay, it is a resistive transducer produced by an external source and based on the principle of potentiometer, that the potential drop across the length of the uniform wire is directly proportional to the length of the wire. Okay, so here the concept is behind that, the potentiometer, when the length of, you know, the resistance is directly proportional, sorry, inversely proportional to the that here you see that it is the resistive transducer. Okay, it is based on the principle of potentiometer. Okay, that the potential drop across the length of uniform wire is directly proportional to the length. That means the potential difference, the resistance of a wire is directly proportional to the length of the wire. Okay, so whenever the length of wire is decreased, then the the resistance also decrease across the across the wire. Okay, so in this concept, on based on this concept, we use potentiometer transducer. Okay, now you see, uh, that is here complete of active transducer and passive transducer, and difference of the active transducer and passive transducer only on that. In active transducer there is no need of external sources for working of the transducer, but in passive transducer there is a need of external source to operate or to functioning as a transducer. Okay, so Now next you see photo cell. Okay, a photo cell, a photoelectric cell. Okay, photo cell or photoelectric cell is a device which convert light energy into electrical energy. It is based on the photoelectric effect. Okay, there are mainly three different kinds of photo cells. Okay, so photo cell is a device which convert light energy into electrical energy. You see, in your solar cell, you know, basically example of this photo cell is solar cell. Solar cell, what is the function of solar cell? Solar cell receive the energy from the sun radiation and convert that energy into electrical energy, and we can use electricity or we can get electricity from the solar cell. Okay, similarly photo cell also convert, or photo cell is um, like the solar cell. Okay, and you see this is the photovoltaic cell. Photovoltaic cell is also called solar cell. Okay, so in this photo cell are of basically three types. One is photoemitter cell. Okay, then photoconductive cell and photovoltaic cell. Okay, now let us discuss about photoemitter cell. Okay, so this cell work on a Einstein theory of photoelectric emission. Okay, a photo emission cell, emitter cell consists of a evacuated glass, okay, or quartz tube, inside of which, okay, there is a semi cylindrical metal plate C, uh, cathode. Okay, and where loop a anode. Okay, and and the tube is covered with a insulating base. Okay, on which metallic pins are projected. Okay, the photovoltaic cell, okay, filled into a socket and it connected to the external circuit having battery, okay, micro emitter, emitter, and load resistance. Okay, so photovoltaic cell, construction of photovoltaic cell is that here you see this is a glass tube. Okay, so here is a glass tube. Okay, and inside the glass tube one C shaped one C shaped anode is there. Okay, sorry, cathode is there. Okay, and one anode is there. Okay, this is the two terminal, and the anode, there is the cathode, and that C. Okay, and this is the anode. Okay, here you see this is the cathode and this is the anode. Okay, this is the anode and this is the cathode. Okay, so this C type, you see this plate C is a cathode, this is, and a wire looped A, and this is the anode, which is wire looped means like sorry, like this is a wire looped. Okay, a wire looped is used as a anode. Okay, now now this is the construction of uh, photo photoemitter cell. Okay, sorry, photoemitter cell. And now on the let us discuss about the working function. Okay, so when light is suitable wavelength, light of when light of suitable wavelength is allowed to fall on the cathode. Okay, this cathode. Okay, then photo electrons are emitted. Okay, due to the light incident on this plate, the emitter, no, sorry, the electron is emitted from this C plate. Okay, which is cathode. Okay, these electrons are attracted by anode. This electron is attracted by anode because anode, here anode, this cathode is negatively charged. Okay, so here, and due to anode, cathode is negatively charged, here electron is more. Okay, so electron emitted. Okay, due to the incident solar radiation. Okay, or solar ray. Okay, then this anode is positively connected to the positive potential. Okay, so this is a positive and this is negative, so electron are attracted towards the positive end, which is anode. Okay, so these electrons are attracted by anode, which is kept at a positive potential with respect to cathode. So a current starting flowing in the circuit. Okay, due to it, micro emitters show deflection. Okay, and the potential photoelectric current is very small, so it is to be amplified fast before it is used for the some useful purpose. When light is cut off, no uh, electrons are ejected from the cathode, hence there is no current. So this is the produce that this is the process when the sunlight is reflected incident on the C cathode plate. The electron started emitted from the cathode plate and attracted by the anode. Okay, then when the electron flow is happened from cathode to anode, and that electron flowing through the circuit. Okay, so one current is flowing through the circuit, but this current is very low. So before using it, this current before using this current for any uh, useful purpose, we should amplify this current. Okay, so this is the concept of photometer cell. Now let us see the photovoltaic cell. Okay, what is photovoltaic cell? Okay, this is based on the fact that when certain material are exposed to light, an EMF is set up across end terminal. This is directly proportional to the radiation energy incident on it. Okay, so photovoltaic cell means is you can consider it photovoltaic cell uh, mm, like solar cell. Okay, so solar cell have that material. Okay, which that material, when sun radiation fall on that material, then that material, the two end of that material have one EMF. Okay, one EMF. Okay, EMF means electromotive force. Okay, due to that electromotive force, there is a potential difference happened between the two terminal, and due to that potential difference, one current is flowing through the circuit. Okay, so this is the basically concept behind the photovoltaic cell. So such material used in that photovoltaic cell. Okay, the most commonly used photovoltaic cell is of barrier layer type iron selenium cell shown in figure. Okay, this type of selenium cell. Okay, this is iron base, then selenium, then barrier layer, then surface film. One terminal here, one next terminal here. Okay, so whenever the sun radiation fall on this material, so after getting the sun radiation, it produce one EMF. Okay, so and that EMF produced one potential difference, it is voltage, and by using that voltage we can get the current. Okay, so this is the concept of photovoltaic cell. Okay, now next is photoconductive cell. Okay, photoconductive cell, what is it is based on the principle that electrical conductivity of material like selenium, cadmium sulfide etc increases when exposed by light. Okay, so the commonly used cadmium sulfide. Okay, this cadmium sulfide, this is the CDS cell, is shown in figure 7.8. This is the cadmium sulfide cell. Okay, when no light is fall on the cell, okay, its resistance is very high and hence current is low. Okay, so whenever there is no light fall on the cell, so the resistance inside that cell is very high, so current flowing through that cell is very low. Okay, when cell is illuminated, that means allow the radiation fall on that cell. Okay, it resistance decreases. Okay, and the current became large. Okay, so the photoconductivity cell is used for detecting shipping and aircraft by the radiation based out of their exposure, okay, exhaust, okay. So now that's all of three types of photocells, okay. Now let us discuss about the application of photocell, okay. Photocells have a large variety of application for industrial and scientific research. A few of these applications are mentioned below, okay. One is in television, okay. Photo electric cell are used in television cameras, okay, for telecasting screen, and they are also used in phototelegraphy, that is a system of transferring picture to a large distance in a short interval of time, okay. And next application is in burglar alarm, okay. A beam of ultraviolet light is allowed to fall on a photo cells across the room. When the burglar walks in the room, the interruption the light which incident a photo cell which incident on the photo cell, okay. Those photoelectric current stop for the moment. This switches and another electric circuit which result in the ringing of the bell. That means here what happened, one photovoltaic is there, okay, photocell is there, one ultraviolet light is always incident on that, okay. Let's this is a room and this is the door, okay. In the door we use this concept, one UV ray is there, UV light is there, and one photo cell is there, okay. Then UV light always incident on the photo cell, so we get a current from the photo cell and the circuit is continue, okay. Whenever a thief is passed through that light, okay, at the time the light interrupt or light stopped falling on the light stopped falling on the uh, photovoltaic, so that whenever the light didn't fall on the voltaic cell, then at the time the current didn't produce from the photovoltaic cell, okay. So current is caught for a little amount of time, okay. And due to current caught, okay, one another circuit electric circuit activated, and that circuit activated the alarm, okay. So this is the concept between the burglar alarm, okay. The next one is in photometry, okay. The photometry, okay, they are used to compare the illumination power of two source and to find the intensity of illumination of the surface, okay. They are you and the fourth one is they are used to determine the opticity of the solid and liquid, okay. They are used to measure the temperature and the temperature of the star and study the spectrum of the heavenly body, okay. and and so on, the application is so on, okay. So uh, this is all about your today's class, okay. Thank you.